Hello friends, welcome back to my YouTube channel Chemistry Basics. Today we are going to see the multiple choice questions on spectroscopy part 2. So in part first we have seen introduction to spectroscopy and UV spectroscopy. Today we are going to deal with IR spectroscopy. So let's see different questions. Before that, if you are viewing this channel first time, then just subscribe the channel and you can share this video and press the bell icon button so you will get the notification of next video. So let's start today's video. So first question, the region of infrared radiations ranges from dash dash. Options are given: A 0.8 to 2.5 micron, 2.5 to 16 micron, 16 micron to 200 micron, and 200 micron to 400 micron, and corresponding values in centimeter inverse are also given in bracket. So what's the reason, or what's the answer? Any guess? The answer is 2.5 to 16 micron. Let's go for the next. The infrared IR region divided into dash dash. Option A, functional group and anti-aromatic region, fingerprint and aromatic region, functional group, fingerprint and aromatic region, and last, functional group, fingerprint and non-aromatic region. So what is the answer? Let's see here, division of IR region, how that IR region is divided. So it is divided into three parts: functional group region, fingerprint region and aromatic region. Hence the answer is C. Next question. The functional group region of infrared ranges from dash dash to dash dash micron. So option A 2.5 micron to 7.7 micron, B 7.7 micron to 11 micron, 11 micron to 16 micron, 16 micron to 50 micron. So any guesses? So let's see here the division of IR region and what are the corresponding wavelengths. So functional group region is ranges between 2.5 to 7.7 micron. If you have fingerprint region, 7.7 to 11 micron. If you have aromatic region, it's 11 micron to 16 micron. So what's the answer? So functional group region, it starts from 2.5 to 7.7. So option A is the correct answer. Which area of the IR spectrum is called fingerprint region? So just we have seen that, but that is in the microns, and here the values are given in centimeter inverse. So option A 4000 to 1300 centimeter inverse, then B 2000 to 1000 centimeter inverse, C 3000 to 1000 centimeter inverse, and D 1300 to 900 centimeter inverse. So what's the answer? It's D 1300 to 900 centimeter inverse. If you are converting that microns into centimeter inverse, you will get that value. Okay. So here it's also given the corresponding wavelength in micron and centimeter inverse is given. So functional group, so 2.5 micron to 7.7. So it's in centimeter inverse is 4000 to 1300. And if you are taking that fingerprint region, so it's having in centimeter inverse that 1300 to 909, and the corresponding micron values are 7.7 to 11 micron. Okay, so let's go for the next question. The number of different ways in which a molecule can vibrate are known as: option A wave number, option B fundamental modes of vibration, option C stretching frequency, and D vibrational frequency. So what's the answer? So it's a very simple question. So the number of different ways in which molecule can vibrate are known as fundamental modes of vibrations. So option B is the correct. The next question, the vibrations which result in change in dipole moment are called as what? So this is one of the important condition for IR absorption. So options A, IR active, B, IR inactive, C, Raman active, or D, none of these. So in IR spectroscopy, those vibrations which results change in dipole moment, only they are absorbing the IR radiation, and that vibrations are called as IR active vibrations. So answer A or option A is the correct answer. The fundamental modes of vibration of chloroform is. So fundamental modes of vibration, how we can calculate that? So options are given 9, 10, 11 and 12. So what's the formula for fundamental modes of vibration? So it's given here. So you should know the geometry of that molecule, just whether it is a linear or non-linear, nothing else. So fundamental modes of vibration for linear molecule it's 3n minus 5, and for non-linear molecule it's 3n minus 6. So where n is the number of atoms. So in case of chloroform, CHCl3, it's a molecular formula and it's a non-linear molecule. So we know that it's a tetrahedral. So as it is a non-linear, so we have to use the formula 3n minus 6. So fundamental modes of vibration 3n minus 6, 3 into 5. So 5 atoms are there, 3 chlorines, hydrogen and carbon. So 3 into 5, that's 15 minus 6, it's 9. So correct answer is 9. Let's go for the next. The fundamental modes of vibration of benzene and acetylene molecules are dash dash and dash dash respectively. So here two compounds are given and we have to find out their fundamental modes of vibration. So again we have to just check it out whether they are linear or non-linear. So we know that benzene is non-linear and acetylene is linear. So let's put that values in the corresponding formula. So for benzene, 12 atoms are there, 6 carbon and 6 hydrogens there, and as it is non-linear, formula used is 3n minus 6. So 3 into 12 minus 6, that's the 30. And if you are taking the acetylene, it's a C2H2, 4 atoms will be there. So n will be the 4 and the formula is 3n minus 5. So as it is a linear. So 4 into 3, it's a 12 minus 5. So it will be the 7. So answer will be 37. So option C is the correct answer. Now rocking is a type of dash dash vibration, whether it is stretching, contracting, bending or twisting. So rocking is the type of which vibration? So let's see here. Some vibrations I have shown here, bending vibrations. So in plane and out of the plane. So in plane there are two vibrations, the scissoring and rocking. So here is the answer, rocking. And out of the plane, that's the wagging and twisting is there. Okay. So rocking is the type of bending vibration. Let's go for the next. The vibrational frequency is inversely proportional to dash dash. A, force constant, B, bond energy, C, reduced mass of atoms, or D, bond length. So we know that vibrational frequency nu is equal to 1 upon 2 pi c under root f by mu. So where nu is the vibrational frequency, then pi and c are the constants, c is the velocity of light, f is the force constant of the bond and which is proportional to the bond energy, and mu is the reduced mass. So if you see here, this vibrational frequency is inversely proportional to only reduced mass because pi and c are the constant values. So answer C will be the correct answer. Next question. The bands occur in aromatic region are due to dash dash vibrations of CH bonds. So whether they are symmetrical stretching, unsymmetrical stretching, bending vibrations or none of this. So always remember that in aromatic region the bend vibrations occurs due to the CH bonds are bending vibrations. Okay. So next question, the electron donating inductive effect dash dash the stretching frequency. Option A increases, B decreases, C unchanged, or D doubles. So what will be the answer? So electron donating inductive effect. So let's take one example. See, it's a carbonyl group which is attached to alkyl groups. Alkyl group shows the plus I effect, electron donating effect. So due to the electron donation, what happens here? So bond length is increases because now double bond character changes to single bond, and whenever bond length is increases, force constant is decreases and IR strength also decreases. So it will decreases the stretching frequency. Next, which of the following solvent is best to use in IR spectroscopy? So in IR spectroscopy, which solvent we can use? Whether it is A chloroform, B methanol, C water, or D ethanol. So if you see here, remaining three B, C, D, they are somewhat polar or weakly polar, but if you are in chloroform, somewhat non-polar one, and hence we can use a chloroform is the best solvent used for IR spectroscopy. Most of the substances are soluble in it. Okay. Question number 14. The IR frequency of carbonyl group in acetone is less than that of acetaldehyde because option A plus I effect of methyl decreases the double bond character, minus I effect of methyl decreases double bond character, plus I effect of methyl increases double bond character, or minus I effect of methyl increases double bond character. So what should be the answer? So all we have know that methyl group shows plus I effect. So methyl group never shows minus I effect. So B and D will not be the answer. So answer should be A or C. So what will happen then? Electron donation effect will be there. Just we have seen in the earlier slide. So when electron donation will be there, single bond character is increases. So in case of acetone, two methyl groups are there. They are showing the more plus I effect as compared to acetaldehyde, and therefore the IR frequency of carbonyl group in acetone is less than that of the acetaldehyde. So option A is the correct answer, that the plus I effect of CH3 decreases double bond character and increases single bond character. Okay. The next question is the IR frequency of carbonyl group in COCl2 increases as compared to acetone because option A plus I effect of Cl decreases double bond character, minus I effect of Cl decreases double bond character, plus I effect of Cl increases double bond character, or minus I effect of Cl increases double bond character. So we know that Cl is not showing plus I effect, Cl is showing the minus I effect. So A and C would not be the answer. The answer should be B or D. So let's see the structures first. This is acetone and COCl2. COCl2 is nothing but the phosgene. Okay. So in case of acetone, methyl group shows the plus I effect, while in case of phosgene or COCl2, chlorine shows minus I effect. Strong minus I effect shows, and therefore this double bond character is increases, and that's why the value of IR absorption is also increases, and hence the answer D is the correct answer, that minus I effect of Cl increases double bond character because acetone is unsymmetrical compound, plus I effect of methyl group increases carbonyl frequency, acetaldehyde contains carbonyl and CH stretching frequency, or none of this. So what will be the answer? Let's see the structures. So here is the acetaldehyde which contains two characteristic groups that can absorb the IR radiation. There is carbonyl and CH. So CH will absorb at 2750 while carbonyl will absorb at 1720 centimeter inverse, and hence it will show the two peaks. In case of the acetone, it's a symmetrical compound, and therefore it will show only one carbonyl stretching frequency at 1710 centimeter inverse, and hence acetone shows a single IR peak while acetaldehyde shows two characteristic peaks because acetaldehyde contains both these reactive or particular stretching frequency of carbonyl and CH bond. So answer C will be the correct answer. Question number 17. The carbon-carbon triple bond shows stretching vibration at. So whether it is at 1300 centimeter inverse, 2700 centimeter inverse, 2100 centimeter inverse, or 3100 centimeter inverse. So we know that carbon-carbon triple bond region, so it will be at 2100 centimeter inverse. Hence the option C will be the correct answer. Characteristic absorption band that will be due to whether it is OH, C double bond C, CH, that CH should be of the alkane CH, okay, and option D is C double bond O. So here it is due to the carbon-carbon double bond. So alkene carbon-carbon double bonds usually absorbs at 1600 centimeter inverse. Which of the following group shows strong absorption band at 1700 centimeter inverse? So option A alkane, option B alcohol, option C ether, option D aldehyde. So 1700 centimeter inverse absorption bands are due to the carbonyl group. So carbonyl group is present in aldehyde. So option D will be the correct answer. The next question. Cyclohexanone absorbs at lower frequency than cyclobutanone. What's the reason? So option A, cyclobutanone has ring strain, cyclohexanone has ring strain, plus I effect of cyclohexyl ring or plus I effect of cyclobutyl ring. So what will be the reason? Let's see the structures. See here, cyclohexanone, cyclopentanone, cyclobutanone and cyclopropanone. So as you are going from cyclohexanone to cyclopropanone, angle strain is increases, and due to that angle strain carbonyl stretching frequency also increases. So as compared to cyclohexanone and cyclobutanone, so angle strain is increases here. So cyclobutanone has the more ring strain as compared to cyclohexanone. Cyclohexanone actually having a very much less ring strain. So option A will be the correct answer. The compounds C4H8O do not show any absorption band above 1500 centimeter inverse due to presence of carbon-carbon double bond, presence of carbon-oxygen double bond, presence of all sigma bonds, and presence of hydroxyl bond. So it is a very obvious question. So though it's containing a oxygen here, if oxygen is in the form of carbonyl, so it should have 1700 centimeter inverse stretching frequency. If carbon-carbon double bond is there, there has to be 1600 centimeter inverse frequency, and when the OH group is there, obviously it is going to 3300 to 3600 centimeter inverse. So all these three options will not be the answer. So what will remaining? So presence of all sigma bonds. So sigma bonds will not go above 1500 centimeter inverse. So what about the oxygen then? So oxygen will be present in the form of ether linkage, and which can absorb up to at 1300. So 1100 to 1300 centimeter inverse, and that's why the correct answer is C, presence of all sigma bonds. Question number 22. 1-butane shows two distinct IR peaks, but 2-butane does not. Option A, 1-butane is symmetrical while 2-butane is unsymmetrical. 2-butane is symmetrical while 1-butane is unsymmetrical. Option C, they have different molecular formula. Option D, both are symmetrical. So what will be the answer? So here it is the structures of 1-butane and 2-butane. So structures, this is for the 1 butane at the carbon number 1 triple bond start, and this will be the 2-butane at the carbon number 2 triple bond start. Okay, so in case of 1-butane, if you see, here is a CH stretching frequency of acetylene. It's very important, and that's why we can easily distinguish the 1-butane and 2-butane. So this particular 1-butane can show CH stretching frequency as well as C triple bond C stretching frequency, but in case of 2-butane, it's a symmetrical structure and hence it will not show that stretching frequency. So option B will be the correct. That is, the 2-butane is symmetrical while 1-butane is unsymmetrical. So question number 23, salicylaldehyde absorbs at lower frequency than benzaldehyde due to option A, presence of intramolecular hydrogen bonding in benzaldehyde. Option B, presence of intramolecular hydrogen bonding in salicylaldehyde. Option C, presence of intermolecular hydrogen bonding in benzaldehyde. Or option D, presence of intermolecular hydrogen bonding in salicylaldehyde. So hydrogen bonding is definitely going to be lowers the absorption frequency, but which compound will show the hydrogen bonding, that we'll have to see. So let's see the structures. So here it is benzaldehyde. There is no any group that is going to be show the hydrogen bonding, so only carbonyl group is present there, and it will show the stretching frequency at 1700 centimeter inverse. But in case of salicylaldehyde, hydroxyl group present at the ortho position will form a intramolecular hydrogen bonding, forming a 6-member cyclic system. So therefore, what will be the answer? Answer will be the B, that is the presence of intramolecular hydrogen bonding in salicylaldehyde. So if you see here, stretching frequency lowers down to 1670 centimeter inverse. The next question, di-substituted alkynes can be distinguished from mono-substituted alkynes by. So option A, C double bond CH stretching frequency, C double bond C stretching frequency. Option C, C triple bond C stretching frequency, or D, C triple bond C H stretching frequency. So as it is a alkynes, A and B never be the answer. The answer should be between C and D. So di-substituted alkynes and mono-substituted alkyne. So usually in mono-substituted alkynes, this particular CH stretching frequency will occur. That is the very characteristic frequency 3300 centimeter inverse, and that is absent in the di-substituted alkynes, and therefore answer D will be the correct answer. So all of you are getting it. So that's all. This is about the multiple choice questions on IR spectroscopy. So thank you for watching this video. If you like this video, so subscribe the channel. So you can press the bell icon button so you will get the notification of the next video, and you can share and comment if you like this video. Thank you very much.